In this video I'm going to show you that the line integral does depend on the path that you take. So for example, if you're trying to get from A to B and you've got some sort of surface, so this is your surface, if you're trying to get from A to B, the line integral from A to B, if you follow the x squared path, will be different from the straight line y equals x. So you taking this path is really you walking along this curve here, and you taking the path y equals x is really you moving from the origin in a straight line to B here. The A is the origin. Okay, so I'm going to show you that the line integral of this will be different from the line integral from here to here. Okay, so let's compute it. So along y equals x squared, this is the formula to work out the line integral. We need to know the speed. So in order to work out the speed, we need the position vector. So if you're trying to drive a particle in a quadratic manner like this, the parametric equations would be t comma t squared, where t is from 0 to 1. So t is from 0 to 1. The position vector would be t, and then in the y direction it would be t squared. So so to work out the speed, we would need to differentiate the position vector once. So when you differentiate t, it would be 1, and then when you differentiate t squared, it will be 2t. So you've got your velocity vector. Once you've got your velocity vector, use Pythagoras to work out the speed. So the speed will be the square root here. So we can now put this into the speed, and our surface was given by this. So this is our x location, this is our y location. We can put it into the x, so that will then give us this. Put this into the y. When you square root t squared, it would just be t, and this is our speed. This is our speed here, dt, from 0 to 1, from 0 to 1. So we are currently at this stage. So now it's just a matter of tidying this up and then integrate. So if you tidy this up, it will then give you this. If you integrate this, it will give you this. Tidy this up, that will then give you this. Evaluate it, and it will give you this. So this is our answer. The line integral, or the area underneath the surface in that quadratic path, will be given by this. Okay, so now let's consider moving along the straight line y equals x. So along y equals x, we would need this speed. We got to set up the position vector. The position vector will be t, where t is from 0 to 1. T is from 0 to 1, t. And then differentiate it. That would give us our velocity vector. So that would be 1, 1. If you differentiate t, differentiate this. Use Pythagoras. The speed would be square root of 2. So now, our line integral is given by this. Okay, because it was this earlier, x plus root y dsc. And then so when you put this into, sorry, hang on, so when you put this into here, that will then give you this. And then our x location is this, which is this thing here, which in turn means this. So that will then give you t. And then this is our y location, which is this thing here. When you put it into here, it would be root t. So now it's just a matter of evaluating this integral. So evaluating this integral, this is just a constant, so drag it out, and then integrate these two. If you integrate this, it will then give you this. Integrate this, it will then give you this thing here, from 0 to 1, and evaluate it, and it will give you this. So you can see that this answer is different from, so the line integral along that the line integral along this straight line is given by this, and this is different from the line integral along this path. Okay, so the two paths are different.